In geometry, the words point, line, and plane are what we call undefined terms. These words do not have formal definitions, but there is an agreement about what they mean. This is not normal in geometry. We have specific definitions for everything. But these basic building blocks have been around so long and are so well known and agreed upon on what they do, no need is around to create a formal definition. So let's talk about what they are. A point. A dot represents a point. A point is a location, and it has zero dimension, meaning it takes up no space whatsoever. So if we have a point, or a little dot there, we're going to name it with a capital letter. We always want to use a capital letter to name our points, because we're going to use points to name other things. What other things, you asked? Well, things like a line. A point has zero dimension, but a line has one dimension. And any 2 points form a line. So if I have 2 points, I have a line. And if I have any 2 points at all, there exists exactly one line. One line and only one line exists that connects those 2 points. And any 2 points on the line, we can use to name it, whether there's 2 points or there's 50 points. So let's bring our point A down and let's give them a partner, point B. And we'll connect them with a line, or exactly one line. And then we have line AB. Or when we write it, we can write AB and draw a line with the arrows over it. The arrows are very important. The line stretches forever to infinity in both directions. And we need to differentiate between a line and other stuff that we'll talk about a little later. Well, in addition to using any 2 points on the line to name it, we could use a lowercase letter like this L, and we could name it line L. All are valid legal ways to name a line so we know what object we're working with. Our third undefined term is plane. And if a point has zero dimension, a line has one dimension, a plane has two dimensions. And any 3 points form a plane. So we go 0, 1, 2 for how much space they take up, and we go 1, 2, 3 on the number of dots we need. So 3 points, we have a plane, which is a flat surface. It's easy to think of a wall or a whiteboard as a plane. And we name a plane by any 3 non-collinear points. So let's go back to our A and our point B, and we know a line connects them. And then down here, let's draw a third point that's not on the line between A and B, C. And this is going to create for us our plane. And just like we named our line with a lowercase letter, we can name our plane with an uppercase letter with no dot. If there's a dot, it's a point. If there's no dot, we're naming the plane. So this plane is plane ABC, or we could call it plane M. And we know that M is the name of the plane because we don't have 3 points. We're not talking about a point. So we used the word non-collinear earlier. Well, that begs the question, what is collinear? Well, linear, line, if points are collinear, they are on the same line. Non-collinear points are points that do not lie on the same line. In fact, let's highlight that knot. And we got to have at least 3, because if we have 2, we automatically have a line that was up above in our definition. So if collinear means points on the same line, logically, coplanar are points on the same plane. And then non-coplanar, points that do not lie on the same plane. And we'll look at some of these things here in just a second, like right now. So let's give 2 other names for line PQ. So line PQ is this line right here. Well, another way we could name line PQ is because we could call it line QP. Because a line stretches to infinity in both directions, so it doesn't matter if I start at Q, go through P, start at P, go through Q, I'm still getting all the same information. And then if you notice right up here, this little n, well, somebody quite helpfully went and named line QP line N, so we could just use that, which, as other names go, is pretty simple. Let's look at plane R. Let's find 2 more names for plane R. So this box here, this flat surface, is going to be plane R. And here's our R. Now let's even switch colors. Go to green. Here's our R. Now, if we go ahead and look back, we know we need 3 non-collinear points to name a plane. So we're going to call it plane, because it is, and we need 3 points not on the same line. So here's one, and here's one. So let's call it plane STV. We're asking for 2 names, so we got to name another one. So it's going to be PSV. We need them not on the same line, and we'll talk about that after a little bit. So name 3 points that are collinear. Well, we only have 3 points on our drawing that all exist on the same line. And that's point S, point P, and point T. If maybe you were thinking about P, Q, and N, N's not a point. So we can't use that. Let's look at 4 points that are coplanar. Well, we already talked about those when we renamed plane R, and they're going to be point S, point P, point T, and point V. Let's do one more example to help us get, in fact, pause the video and try this yourself, and then restart and we'll see how you did. All right, so you tried it. let's find line DE. So we can call it line DA. We can call it line ED. We can call it line R. We could call it line AD. All are legal. And hopefully you got 2 out of those 4. So plane C, this one right here. So we know we need 3 non-collinear points. So it could be plane ADF, or it could be plane AEF, or we could name it plane DEF. All would work, and those letters can pretty much be in any order. I personally prefer to have them in alphabetical order because that's my sense of order. So let's look at 3 points that are collinear, which you already did. Points A, D, and E are all on line R. They are collinear, and 4 points that are coplanar. We have A, D, E, and F, all on plane C. So good job. So those are undefined terms, kind of how we use them, and they're the basic building blocks for the things that we're going to do. So let's talk briefly about defined terms, segment and ray. And we're going to use points A and B and the parts of line AB to define these. So a line segment or segment is a part of a line that consists of 2 endpoints, meaning there is a start and there is a stop. So let's bring our line AB down. We're going to do a segment. So it means we're going to start and we're going to stop. Because what we have are endpoints, and these are our endpoints. And when we name this bad boy, we're going to call it segment AB, or we're going to call it AB and draw a little line segment above it. And if you remember, when we named the line AB, we did the arrows. No arrows on a segment. We want to show that there's a start and a stop to these. Rays, like a ray of sunshine. A ray is part of a line that consists of an endpoint, and all points on the line on one side of the endpoint. So let's go back to our AB and see what that looks like. So we have an endpoint, which means one endpoint, and then all the points on one side of the endpoint. So we have endpoint A, we're going through point B on forever out into infinity. And we're going to call that ray AB. And if we don't want to write ray all the time, we can draw a little ray over AB for ray AB. Now, when we write array, the name of array, we always do the endpoint first with 3 exclamation points. And the reason we do that is because we're starting at our endpoint and we're going out through another point onto forever. So we need to know where we start. Well, we're starting at A. That's what this ray tells us. The last one we're going to talk about is opposite rays. And opposite rays are two rays that have the same endpoint and form a line. So let's do our AB. And for this purpose, we need to add another friend in, so we're going to add C. So let's do this. So we got ray CA. Maybe? Ray CA. And we got ray CB. So ray CA and ray CB are opposite rays. They start in the same place at point C, and they go in opposite directions, forming a straight line. That's the definition of an opposite ray. So let's take this information and put it together and see if we can't use it. So give another name for segment GH, and GH is right here. Well, another name for segment GH, starting at G, ending in H, would be segment HG, where we start at H and we end at G. Doesn't matter which direction we're going to capture all the data from G to H or from H to G. It's the same information, so we can name it in either direction. So let's name all the rays with endpoint J and see which one of these rays are opposite rays. Well, we start with the endpoint, so J is going to go first. Let's just go around the horn. So we get ray JG, we get ray JF, we get ray JH, and then we get ray JE. So let's look, what are opposite rays? Well, they all start with the same endpoint. And do they then form a straight line is a question. So if we start with the first two, JG and JF do not form a line. So they are not opposite rays. How about JG and JH? They do form a line. So these are going to be opposite rays. What about JF and JE? Also form a straight line, also have the same endpoint, so they are also opposite rays. Go ahead and give this next one, pause the video, give this next one a try, and then we'll look and see how you did. All right, let's look at another name for TR right here. So TR is going to be segment RT. Oops. Because it doesn't matter which direction we're going. So name all the rays with endpoint P, and P is right here. So once again, we're going to go around the horn. So we got PR, PS, ray PT, and ray PQ. Our opposite rays, we start with PR. Well, we need the other side of that line, PT. Then we go to PS right here, need the other side, PQ. Same endpoint, form a line, opposite rays. All right, so last one. Once again, pause the video, try these 3 questions, and then come back and see how you did. All right, so KL, just like the 2 above us, segment KL, so we need everything between K and L, and the only way we can do that with a new name is to rewrite it as L, segment LK. So RKP starts at K, goes through P in this direction, and PK, which starts at P and goes through K, the same ray. Well, no, we see green that's not covered by orange. So no, they have different endpoints. So by having different endpoints, they automatically are going to have different information included with them. So we can't count them. Okay, so let's come to our third one, NP. So NP is going to go N through P right here, and NM, that light blue, N through M right here. They are exactly the same. Yes, they have the same endpoint. And remember, the first letter is always the endpoint, and they go in the same direction because they go on forever in whatever direction they're going. They will encompass all those points. So they are indeed the same ray. All right, so last thing we're going to talk about in this section are intersections. So when we have 2 or more geometric figures, 2 lines, 2 planes, a line and a plane, they intersect when they have 1 or more points in common. Those are the places they touch, like a road intersection. Like a road intersection. At that stoplight, both those roads intersect. Well, here we have 2 lines, line M and line N, and they're touching each other at point A. The intersection of 2 lines, these 2 lines, is a point. And the intersection of any 2 lines is always going to be a point. Now we're going to come over here and look at our planes. And the intersection of these 2 planes, right here where they come together, is a line. We can see that straight line by where the 2 planes come together. If you think of a ceiling and a wall in your home, where those 2 flat surfaces meet, there's a line. We call it a corner, but it's a line. And if that wall extended forever and that ceiling extended forever, that's still the only plate they touch is along that corner or that line. So given what we've just talked about planes and lines and intersections, I want you to pause the video, do these questions, and then let's see how you did. All right, so the intersection of PQ. Line PQ is right here. Line K is this line right here. And where do they intersect at? They intersect at point M. All right, so the intersection of plane A and plane B. So here is A, right here, let me trace it out. Here's plane A. And here's plane B. Well, that's a classic wall and ceiling corner, right? So they're going to intersect on line K. So I wish I could sit there and ask you what the intersection of line K and plane A, what answer you got, but let's think about it. If our notes here are plane A, and I draw this line, which is line K, every single point on line K is on my piece of paper. So K exists on plane A. So every point that's on line K is on plane A. So where do they intersect each other? Where do they touch? They touch at line K. So feel free to go back and rewatch this video if you have any questions. Until next time.